It's hard for us to fully grasp just how vast space truly is. We're most comfortable within the bounds of our own solar system, where planets like Earth, Jupiter, and Mars feel familiar. But beyond the edge of our solar system, past the heliopause, more than 18 billion kilometers from the Sun, leaves the dark, frigid emptiness of interstellar space. Only two man-made objects, the Voyager probes, have ever crossed into this abyss. Similarly, only two objects have ever made the opposite journey, from the depths of interstellar space into our solar system. These were the well-known interstellar visitors Oumuamua in 2017 and Borisov in 2019. Their arrivals stirred a sense of wonder and perhaps a touch of fear about what might lie beyond the reach of humanity. For 6 years, space remained quiet. But a new discovery has reignited our curiosity. NASA recently confirmed the observation of a new interstellar object, Tri Atlas, the third such object ever detected making its way into our solar system. This unusual visitor will swing by our sun before the end of the year. It was first spotted on July the 1st by the Atlas Survey Telescope in Chile, part of a network that includes observatories in Hawaii and South Africa. The Atlas system scans the night sky for objects that may pose a threat to Earth, taking hundreds of images every night. One of its unique strengths is its ability to photograph the densely packed galactic plane, something many surveys avoid due to overexposure. On this particular July night, Atlas picked up an object from the direction of the Sagittarius constellation, moving straight toward the solar system. Initially labeled a 11PL3Z, the object quickly attracted attention from the Minor Planet Center, MPC, which is responsible for tracking such bodies. They soon discovered that other telescopes, including the Zwicky Transient Facility and additional Atlas stations, had unknowingly recorded the object weeks earlier, dating back to mid-June. When all this data was analyzed, the object's orbit stood out as hyperbolic, indicating it came from interstellar space. That revelation earned it the designation 3I Atlas, signifying it as the third interstellar object on record. At first, astronomers weren't sure whether it was a comet or an asteroid, but subsequent observations confirmed the presence of a coma, a fuzzy halo of dust and gas that forms as solar radiation, causes surface ice to vaporize, classifying it as a comet. Its full name now is C 2025 N1 the Di Atlas. The MPC has requested more data to refine its trajectory, and scientists around the globe are eagerly responding. Michele Bannister, a researcher who worked on the earlier interstellar objects, called these events transformational opportunities, and it's easy to see why. Fortunately, there's no danger of this comet hitting Earth. Its closest approach will still be about 1.6 astronomical units away, over 600 times the distance between the Earth and the Moon. That means we can safely observe it and learn about its voyage. 3I Atlas follows a highly eccentric orbit with an eccentricity of around 6. For comparison, a value above 1 indicates an object can escape a gravitational pull entirely. With such an extreme orbit, this comet has been free, roaming through space, and it's now rocketing through our solar system at 58 kilometers per second, nearly double the speed of Oumuamua and Borisov. It will reach its closest point to the Sun on October the 30th at a distance of 1.4 AU, just inside Mars' orbit. After that, it will loop back out into the cosmic void. The shape of its orbit is strikingly similar to Borisov's, but it doesn't swing in as close as Oumuamua did. With the confirmation of its interstellar origins, astronomers have started employing telescopes from the Las Cumbres Observatory to study it more closely. Their instruments are ideal for capturing transient events like comet flares or changes in brightness. By observing 30 Atlas over time, they were able to construct a light curve and determine that it rotates about once every 29 hours. Interestingly, its light curve is much flatter than Oumuamua's, with only minor variations in brightness, just 0.2 magnitude over its rotation period. Still, the comet is very bright. Between late May and its discovery, it quickly brightened from a magnitude of 20 to about 17.8 in the Atlas O band. Its nucleus is estimated to be roughly 10 kilometers in diameter, much larger than Oumuamua and even bigger than Borisov. Despite this, its activity remains relatively modest. A faint coma surrounds its nucleus, and it has a short tail measuring just 3 arcseconds across the sky. This tail often blends into the coma in images, but it's there nonetheless. Amateur astronomers are also participating in the observations, and online forums like the Astronomer Telegram are full of daily updates. Some contributors like Miguel Alarcon and his colleagues estimate that the tail could stretch over 25,000 kilometers. Public engagement is helping us learn more, faster. When it comes to the comet's color and composition, 3I Atlas again stands out. It's redder than the Sun and even redder than D-type asteroids from the outer asteroid belt. Some of this light likely comes from the coma, which makes it harder to analyze the nucleus directly. The same challenge applied to Borisov, whose dust production obscured the core. In fact, Borisov was found to be shedding dust at about 50 kilograms per second. Whether 3I Atlas is similarly active remains to be seen. After analyzing its appearance, astronomers are using its discovery to estimate how many interstellar objects might exist. Based on the fact that only 0.1 such object was found in 3 years of sky scans by Atlas, the current estimated density is 0.001 interstellar objects per cubic astronomical unit. That's far less than earlier predictions based on Oumuamua and Borisov. The number could still change, especially if smaller objects are slipping by undetected or if these visitors have properties that make them hard to spot, although our current understanding is limited. 30I Atlas has already given scientists a lot to think about. Compared to Borisov, it appears to be less active. Borisov's tail was around 140,000 kilometers long and showed significant cometary outbursts, even from distances as far as 4.5 off from the Sun. 3I Atlas is already closer than that, but we're not seeing the same activity level. Then again, Oumuamua wasn't active at all, likely a dense rock with no surface ice. Its odd shape and lack of tail remain a puzzle to this day, with some theories suggesting it released gases in ways that didn't produce visible dust. So, 3I Atlas may fall somewhere in the middle of these two. Its behavior, its speed, shape, brightness, and composition makes it a distinct entity altogether. One intriguing clue about its origin comes from its velocity. Objects tend to increase in velocity over time as they get jostled by gravitational interactions, based on Sri Satellus velocity of 58 kilometers s. Scientists estimate it could be between 3 to 11 billion years old. That would make it the oldest interstellar object we've ever encountered, potentially 3 times older than Borisov and much older than Oumuamua. While we can only speculate about where it came from, the uniqueness of 3I Atlas ensures it will be a key subject of study. The scientific community is watching closely, eager to extract every bit of information it can offer, whether it's a relic from a distant red dwarf system, a fossil from a planetary collision, or something else entirely. One thing is clear, it traveled across the stars just to pass us by. For now, we wait to see what secrets it may reveal as it journeys through our skies. Keep your eyes open from September through December when the comet becomes visible again after perihelion. You can even track it online using NASA's JPL Horizons tool. Who knows what else we'll discover before it disappears forever into the darkness of space.